Thank you. So yes, my name is Hegh. I'm the ANFF Fibre Research Engineer at Deakin, and I'll be talking about regenerating yarns and colours. This is going to be a bit of a different talk, less technical and more about what's happening at Deakin and our pivot towards circular economy and utilising the ANFF infrastructure down at IFM. So, Deakin University. So there is an institute. We're the Institute of Frontier Materials. Our initial primary goal is imparting materials with extraordinary functionality. Now, in the last couple of years, there's been somewhat of a pivot, and we now have a second mission, and that is redesigning materials for a circular economy. Within this, IFM consists of four main themes: energy and electric materials, advanced alloys and infrastructure materials, carbon fibre and composites, and fibres and textiles. Now, I mostly sit in fibres and textiles, and that's what ANFF is down there to do. And underlying all of that is the advanced facilities and platforms which I manage. Now, what we have electro spinning, melt spinning, and wet spinning production capabilities. We're normally doing things like carbon fibre, nanofibres for masks and filtration, advanced plastics, 2D materials for fibre supercapacitors. Some of our talks today and previously have discussed that. However, with this new pivot to circular economy, we're going to utilise some of that material to start recycling some of these materials that we produce and then just throw away. So we recently got an ARC research hub for functional and sustainable fibres up and running that got accepted earlier this year. That's a $12 million project with 10 companies over 5 years. Within that, a lot of these companies are apparel companies and are not very well versed in the materials that they're actually selling and making, and they want to be more sustainable, so they come to us and want to know more. So a lot of the challenge actually is the textile industry. So this is going to be pretty horrific. The textile industry is the second worst polluter behind the petrochemical industry. Australians, we consume 27 kilos of apparel textiles every year. That's half a million tonnes gets thrown into landfill every single year. We're the second worst behind the Americans, who are about to hit 42 kilos. And it takes 1 litre of water to produce 1 kilo of textiles, and 93% just end up straight in the landfill. So this is actually a reasonably serious problem. But what we really need is we need a circular demonstrator to demonstrate the capabilities at Deakin and that and show industry that we are capable of assisting them in their problem. So this is the target that we chose was regenerated cotton. Cotton is a cellulose material. The consumption is 30 million tonnes of cotton by 2029. And it requires 5 to 20,000 litres of water to grow 1 kilo, and it uses 3% of all arable land. The reason why I chose regenerated cotton is because we produce a lot of it in Australia. There are a couple of ways already to turn old cotton textiles into new cotton materials. One is the viscose process, and that's a 100-year-old process which uses carbon disulfide and sulfuric acid to make the material. Carbon disulfide is extremely toxic. Sulfuric acid is not great either. It gets discharged straight into the water. There's the NMMO process, which is a more advanced process and makes a better material. Both of these are rayons, if you read the back of your label. Now, the challenge with these is the colour is not preserved, and colour requires at least 100 kilos per litre of garment, per kilo of garment to dye, and a lot of that effluent goes straight into the waterways of India and China, because NMMO is oxidizing, and well, not many dyes survive H2SO4. So we decided to choose a project at Deakin which involves the wet spinning capabilities. This wet spinning machine is heavily used for things like carbon fiber, but it's very adaptable. There was an existing project that required some scale up, required my help, so we decided to kill two birds with one stone. They're using ionic liquids to recover coloured cotton. So basically, you take the waste textile, you grind it up, you powder it, and then you dissolve it into these ionic liquids. And then from that, you can spin a range of materials. And then you can knit a textile demonstrator. So for those of you who are not here, it doesn't have quite the same impact, but we decided to create this textile demonstrator. The advantage is that it's got 100% retention in the dye. We can also take powdered materials, powdered cellulose that is coloured, and add them together to create different colours. So the purple in that scarf is actually composed of red and blue. And within this, during this process, because a picture tells 1,000 words, a video tells even more. So we also prepared a video for promotional purposes. Due to technical issues, Tom, can you please play the video?
I'm Nolene Byrne from the Institute for Frontier Materials. I've been researching textile recycling for the past 5 years. Textiles are accumulating in landfill around the world. The amount of land available to grow textile fibres such as cotton is also diminishing. Using cotton waste as a raw material for regenerated textile fibres diverts textiles from landfill and meets the increasing demand for these fibres. The facilities for fibre and textile research at the Institute for Frontier Materials are some of the most advanced in Australia, under our overarching theme of designing materials for a circular economy. We work particularly on the sustainability of processing and the huge problem of textile waste. We have developed a process for chemical recycling of cotton from waste textiles into high-quality regenerated cellulose fibres. Using a green, recyclable solvent and waste cotton instead of wood pulp as the cellulose source gives the technology an environmental advantage over commercial regenerated cellulose fibres. Another environmental benefit is that we can retain the dye on the fibres throughout the recycling process. Dyeing and colouring are the most energy-intensive and polluting part of textile manufacture. Our novel pre-treatment process allows the fibres to retain their original dye, eliminating the need to re-dye recycled textiles. Fibres made from synthetic polymers are strong and durable. However, their poor moisture absorbency can make them uncomfortable. These fibres are also non-biodegradable and can persist in the environment for many years. By contrast, cellulosic fibres can achieve high strength and remain water absorbent, leading to strong fibres with an excellent feel, with the added benefit of being biodegradable. Applications for these fibres include clothing, household textiles, specialty paper, medical dressings, hygiene products, and many more. Unfortunately, the level of textile recycling is very low, with only about 1% of clothing waste being recycled globally. Our technology can take used clothing and convert it back into new fibres, diverting this waste stream away from landfill. We begin by taking waste cotton and shredding it into tiny pieces. This allows for faster, more efficient chemical treatment and dissolution. The shredded fabric is now ready for pre-treatment. The pre-treatment is necessary to allow dissolution of the cotton. This process is crucial as the chemicals used do not interact with the dye on the fibres. After pre-treatment, the coloured waste cotton is dissolved in a recyclable solvent known as ionic liquid. The result is a viscous honey-like liquid that is ready to be solidified and shaped into fibres. The solution is loaded into the spinning line extruder, after which the line can run autonomously. The cellulose solution is transformed into fibres by wet spinning on our pilot scale spinning line. This involves the solution being forced through small holes into the water bath where the fibres are coagulated. The spinning line allows the fibres to be stretched, which gives the fibres its high strength and small diameter. The wet spinning process produces bobbins of fibres that can be used to produce new fabric. Once they have been washed and dried, the bobbins are taken from the wet spinning line to the knitting device. At this stage, many bobbins work together with the knitting machine to combine the fibre bundles into fabric. Because the dye is retained throughout the process, the fabric will not require further dyeing and is ready to use. The materials and processes used here create fabrics with a luxurious experience and a soft feel. The fabrics are strong and elastic, as well as being made from 100% waste and being completely biodegradable. At IFM, we are always looking for opportunities to expand our research and make more connections with industry and other research institutions. We also welcome inquiries from PhD and Masters by Research candidates who are interested in joining our team.
Okay, so that's the video we used for promotion and the textile demonstrator. The inspiration was a Doctor Who scarf. Hopefully it came off, but that's what we're doing at Deakin at the moment. Thank you for listening. I'd like to acknowledge my supervisor, Professor Joselita Rizal, and the group who enabled the primary research for the demonstrator under Associate Professor Byrne, and these are our current Deakin partners. Are there any questions?
Thank you for a very interesting talk there. As a good chair shoot, I was thinking up questions, but the people on Slido have stolen again all my questions, so I'll just ask them and enjoy the answers. So from Katazania, I believe the separation of waste is the largest challenge in the textile recycling at the moment. How are you going to tackle separation of the material, the cotton, from the waste stream?
Yeah, so that is a big challenge. Mainly that is cotton and polyester blends. The big challenge is unmixing an omelette. Entropy is a nightmare. There are ragging and tearing abilities to deconstruct textiles, and we can dissolve one material from another. There is a company called Blocktex at the moment. They are specifically commercializing such technology, and they're using the polyester, and they end up with all this cotton. So there is work in Australia undertaking this.
Thanks, Dylan. So from Coco, how much water is required to obtain 1 kilogram of fibre from recycled fabrics?
Okay, so the only water consumption is in the spinning process, and the spinning process can recover the water and separate off the ionic liquid from the water and recycle it. So it is very, very water efficient compared to growing cotton.
Okay, so many questions coming through. This is fantastic for you, but not for me. Okay, there was a question about sorting you talked about sorting the fibers of the different types of materials. What about different colors? Can you handle it if you've got mixtures of different colors in your
Yeah, so basically if you get a whole bale of say cotton t-shirts and they're all different colors, you're going to end up with brown. But there is a company out of New South Wales, the Circular Centre, who works with another company in Queensland where they employ people with disabilities to help sort these materials. And then along with that, they also use automated sorting machines. So there's robot arms that can determine the composition of the materials or the colour, and then sort it into different bales. So that's already automated.
Thanks, Dylan. I'm just going to sneak one more question in. Apologies to those whose questions I couldn't get to. I want to ask about the ionic liquid itself, and there's been two questions on the recovery of it, and you said it was recyclable, what the video did. So can you explain how the ionic liquid is, I guess, separated and used again in your process?
Yeah, so that is actually a bit of a remaining challenge. Separating ionic liquid off water is still a remaining question, and is one of the challenges in this process, both internally with our project and externally with other people working on ionic liquids. It does take quite a lot of energy to separate it. It is separable, but it needs work.
Okay, well, I think we'll leave it there. Thank you very much, Dylan, for your talk.
Thank you.
I should add, Tom flagged to me that I should congratulate you, Dylan, on using a ANFF face mask in the promo as well. So extra bonus points for that.